Chapter 13 is going to be bouncing a little bit all over the place, but its primary focus is going to be on graphing things on a number line and on the coordinate plane, which is just a fancy name for where we put two number lines, one left and right, one up and down. In the first lesson, we're going to talk about inequalities on a number line. So an inequality is an algebraic statement. So that means there's going to be a variable. Algebraic means there's going to be a variable that contains a less than symbol, greater than symbol, less than or equal to symbol, greater than or equal to symbol, or a not equal to symbol. This chart here is true when the variable is on the left side of the inequality, which I'm reasonably certain all of our problems in 6th grade will put our variables on the left side. But in the future, in pre-algebra, algebra 1, and beyond, sometimes the variable will be on the right side. And then this table isn't quite right. So, you can see things like open, that being empty dot, or a closed, which means filled in dot, shade left, shade right. Let me show you what this looks like in practice. When you're graphing inequalities, you must put two numbers on the number line, 0 and the number we're interested in. So we're just going to graph these four so you can see how this works. X is less than 4. To graph that, I'm going to put a number line. I'm going to put 0 and I'm going to put 4 on the number line. I'm not going to put 1, 2, and 3 because you're going to get answers. You're going to have problems with like 7. You might have 10 or 12 or 25. And I don't want you counting and writing out 0, 1, 2, 3, 4 all the way up to like 25. That's going to take more time than is necessary here. So just put 0 and put the number we're interested in. Now, this says x is less than 4. If I come up to my table, less than is this symbol right here, which means, according to the chart, I should have an empty dot and shade left. So an empty dot really just means put a circle above the 4. That's all an empty dot is. It's a circle. A closed dot would be a circle that's filled in. Shade left. Now, the easiest way of doing that is just drawing an arrow to the left out of that circle. That's a complete inequality. It's graphed. We're showing everything less than 4. The reason you see the word shade is in some places, in some schools, in some classrooms, you're taught to put that circle right on the number line at 4 and then to fill in the number line on the left side. And that's called shading. That, especially since I encourage you to use pencils, takes up a lot of lead. So I don't generally ask you to do that. I prefer the circle to be above the number line and just to draw an arrow coming out of it. It's neater and it wastes less of your resources. So the next inequality says x is greater than 7. So I'm going to put down a number line. I'm going to put 0 and 7 on that number line. Greater than is here, so we can see that's an empty circle and shade right. So I'll put an empty circle above the 7. Maybe I'll actually try putting that empty circle above the 7. And a shade right means put an arrow to the right. Next up, we have x is greater than or equal to 1. So I put down my number line, and I'm going to put 0 and 1 on the number line. And notice I'm not worried about how far away my numbers are from 0. I just want them to be on the right side of 0 since they're all bigger than 0. So this has greater than or equal to, which is this symbol. So it's on the shade right and filled in area. So when I go above 1 and put my circle, I'm going to fill it in. And then I'm going to draw an arrow off to the right. Last one for you to see is less than or equal to. I know I talked about this not equal to symbol, but it's not going to really crop up for a while. And by a while, I mean maybe next year, maybe the year after. So x is less than or equal to 5. Again, I'll put down my number line. I'll put down 0 and 5. Less than or equal to is right here. So that is a closed dot and shading left. So above the 5, I'll put a circle and I'll fill that circle in. And I'll put an arrow to the left. Now, how we're actually going to use this. We are going to have to solve inequalities. And as you look at these 3 examples, they should look like one-step equations from Chapter 11. And we will solve them like we would have in Chapter 11. It's just after we solve, we're going to have to graph the solution. So this first inequality is x plus 5 is greater than 7. So if I see addition, I'm going to subtract to solve. And I'm going to have x is greater than 2. To graph that, we put our number line. We put 0 and 2 on the number line. And greater than means an empty circle, arrow to the right. 3x is less than or equal to 18. 3x is multiplication, so we undo that with division. I will divide both sides by 3. That will get me x is less than or equal to 6. So on our number line, we'll put 0 and 6. Less than or equal to means I fill in the circle I'll put above the 6, and my arrow will go to the left for a less than. And last example here, I have x minus 2 is less than 6. When I see subtraction, I'm going to add to solve. So we're going to add 2 to each side. X is less than 8 is the solution. And to graph that now, we put 0 and 8 on the number line. Circle above the 8, we leave the circle empty because this is a less than inequality. It does not have the or equal to. And less thans get arrows to the left.